Electric dipole. Today I am going to discuss about the electric dipole. Actually, what is electric dipole? Two equal and opposite charges, a pair of equal opposite charge kept at a small finite distance. So this system is called actually electric dipole. See, suppose one charge I have taken minus of q, another charge I have taken plus q. So this minus q charge and plus q, equal and opposite charge, kept at a small distance, finite distance I have taken 12. So this system is known as pair of equal and opposite charge kept at a finite distance. So this system is known as electric dipole. Here I have made a electric dipole. O I have taken as center. Actually, we are taking the small distance as 12 for convenience. Actual what are happening if you are taking the distance from dipole, so you cannot take from plus q, you cannot take minus q. So you have to take from the central point. That's why this distance we have taken 12. It is easy for calculation. So see, electric dipole, two equal and opposite charge kept at a small distance, the line joining negative charge, positive charge. So actually this is known as axial line. The line joining negative charge to positive charge and a perpendicular line. A perpendicular passing through center, perpendicular to axial line. So this is called as equatorial line. Equatorial line. To see, the line joining negative charge, positive charge, this is axial line. A perpendicular line passing through center, that is called equatorial line. See, the strength of dipole, we are measuring by another physical quantity. That physical quantity is known as dipole moment. So strength, what will be the strength? It will be strong, weak. How dipole will work? Okay. So for this measurement, we are taking another. We have considered another physical quantity. That physical quantity is known as dipole moment. To see what is the dipole moment? The dipole moment is product of magnitude of one charge, because same magnitude are there. The product of magnitude of one charge and finite distance between the two charges. This product is known as dipole moment. This shows the strength of electric dipole. Here we can see minus q plus q we have taken. So what will be the dipole moment? It is denoted by P. So dipole moment of electric dipole is defined as product of one of the charge and distance between the two charges. P is equal to Q into 2L. Here you can see dipole is a vector quantity. So what will be the direction? So direction of this 2L is from negative charge to positive charge. Suppose this have point A, this is point B. So 2L mean vector AB, negative to positive charge. Directed negative to positive. Directed from negative charge, negative to positive charge. So negative to positive charge will be the direction of dipole moment. So you can see here the direction of dipole moment will be along AB, mean negative charge to positive charge, and magnitude of dipole moment is Q into distance between the two charges, which I have taken as 2L. So Q into 2L. So see, what is electric dipole? A pair of equal and opposite charge separated by a finite distance is called electric dipole, first thing. And strength of electric dipole we are representing by dipole moment. So product of magnitude of one of the charge and finite distance between equal and opposite charge is called as dipole moment. Here one electric dipole I have shown, minus q plus q separated by plus 2l distance, finite distance. The line joining negative charge to positive charge, this line is known as axial line. The perpendicular line passing through center is known as, and perpendicular to axial is known as equatorial line. The direction is from negative charge to positive charge, that is 2l. So P is equal to Q into 2l. Just see here, practically we can see there are two type of molecules, polar and non-polar. So if you see polar molecules, for example, suppose you have taken HCl. In HCl molecules, this is polar molecules. So what happen? The bonding pair electrons which has shared, they are slightly moved towards chlorine. Electronegativity is more. If bonding pair electrons that have shifted towards chlorine, so this has a slightly negative charge, here slightly positive charge, so automatically the polar molecules, they are forming a dipole. So this plus q and a small positive charge and a small negative charge, they are forming a dipole inside the pair molecules and directed from chlorine atom to hydrogen atom. तो you can see जो polar molecules हैं वो कैसे बिहेव करते हैं, इलेक्ट्रिक डायपोल. ठीक है, ऐसे हम देख सकते हैं H2O. अगर हम वाटर का देखें तो वाटर मॉलिक्यूल्स, ठीक है, दे आर नॉट लीनियर, वो लीनियर नहीं होते, फॉर्मिंग लाइक दैट ऑक्सीजन मॉलिक्यूल्स. ठीक है, and here hydrogen molecules, angle between them is about 104 degrees, 79 mean about 105 degree angle is there between the OH bond. So see here, they are not linear, and electronegativity of oxygen is more than hydrogen. That's why what happen, ठीक है, it gets slightly positive and this is negative and this is also positive, so they are forming dipole. So permanent dipole, here is dipole effect. So H2O, water molecules, so they have also permanent dipole moments. Okay, and here two dipole they are forming, negative positive, here also slight negative positive, so they are also forming electric dipole and they have नेट डायपोल मोमेंट. तो हम देख सकते हैं यहाँ पोलर मॉलिक्यूल्स जो होते हैं वो कैसा होता है, ठीक है, दे आर बिहेविंग लाइक ए इलेक्ट्रिक डायपोल. ऐसे आप NH3 देखोगे तो दे आर आल्सो हाइड्रोजन फ्लोराइड. ठीक है, ये सभी कैसा बिहेव करते हैं, पोलर मॉलिक्यूल्स हैव ए परमानेंट इलेक्ट्रिक डायपोल एंड दे हैव ए परमानेंट इलेक्ट्रिक डायपोल मोमेंट. हाँ, if non-polar molecules is there, for example Cl2, H2, ठीक है, their dipole moment is zero, mean they are not passing electric dipole. But if you're talking about the polar molecules, so they have permanent electric dipole moment. See here, when we are talking about the unit, the unit of dipole moment is coulomb meter. Coulomb into meter. One another unit is, that is debye. So debye unit, what is the relation between them? You can see here 1 coulomb meter is equal to 3 into 10 raised to 29 debye. ठीक है, तो इसके दो यूनिट्स हैं, कूलम मीटर और एक अनदर यूनिट है डेब्ये. ठीक है, डेब्ये और कूलम मीटर में क्या रिलेशन है, तो 1 कूलम मीटर इज इक्वल टू 3 into 10 raised to 29 debye. See here, if we have taken a negative electron charge minus C and plus E, they have separated distance is 1 angstrom. So what will be the dipole moment here? The dipole moment is equal to product of charge into distance between them, that is 1 angstrom. So 1.6 into 10 raised to minus 19, 10 raised to minus 10. So 1.6 into 10 raised to minus 29. So you can see here, this is Coulomb meter. If you are converting in debye form, so this is equal to multiplied by 3 into 10 raised to, so that is 4.8 D. So dipole moment between the when two one electron, negative electron and positive charge electron, they are separated 1 angstrom distance. So in that time the dipole moment will be 4.8 dB. So dB is a unit of electric dipole moment. If we talk about the water molecule, then it is about dipole moment of water molecule to 1.85 dB. The water molecule. So what will be the about 1.85 dB will be the dipole moment between oxygen and hydrogen. See, when the dipole is kept inside a uniform electric field, so it experiences torque. We are going to calculate torque acting on electric dipole in a uniform electric field. How much torque will act? To see, consider an electric dipole P, whose dipole moment is P, is placed in uniform electric field E. This is equal distance. We are taking the lines, they are uniform electric field. Okay. The parallel and equal spaced. This electric field E is there, and dipole minus q plus q at distance 12. So they are kept in uniform electric field. The axis of electric dipole, so this is the axis along AB, makes an angle theta with the direction of electric field. So this angle is theta. You can see here, this angle is theta. They are making with electric dipole. This axis makes with electric dipole. So what will be the torque? What will be the moment of couple acting on this electric dipole? So see here, if plus q charge is kept inside the field, electric field E, so it experiences force. The force acting on charge plus q due to field E. So what happened? This force F is equal to Q into E. Magnitude is QE and direction will be along E. So this will be the force acting on this QE. Direction will be magnitude QE and direction will be the same as direction of electric field. Force acting on charge minus Q due to E. What happened? So this force will be implies by, that is minus q charge is there. You can see here the magnitude will be QE, but minus sign is there. Opposite of electric field. So opposite of electric field mean magnitude will be QE, but opposite direction. So here plus QE, here this is minus QE, opposite direction. So two equal and opposite forces acting at different points, so they will form torque. Two equal and opposite forces acting at different points, so they are forming torque. Equal magnitudes but opposite direction. QE force is acting, QE is acting, and their direction is opposite, and point of action is different, so they will form torque. So what will the value of torque? A moment of couple. So torque acting on dipole, उसी को हम क्या कहते हैं बच्चों? मोमेंट ऑफ कपल. ठीक है, ड्यू टू इक्वल एंड अपोजिट फोर्सेस. तो टॉर्क इज इक्वल टू मैग्नीट्यूड ऑफ वन ऑफ द फोर्स, मैग्नीट्यूड ऑफ वन फोर्स एंड डिस्टेंस बिटवीन द पैरेलल फोर्स. पैरेलल फोर्स के बीच में परपेंडिकुलर डिस्टेंस, perpendicular distance between parallel forces. So what happened here? The value of force, that is QE, and what will be the distance between these parallel forces? So suppose this I have taken here and one perpendicular I have drawn. So perpendicular, suppose this is n. So distance between these two parallel forces will be Bn. So this will be the perpendicular distance between the parallel force. So this will be the Bn, this distance. See here, this angle is theta. So what will be the Bn? You can see here, if you are applying here sin theta, so sin theta is equal to, in this triangle BNA, this is 90 degree. So triangle, right angle triangle BNA. So in triangle BNA, sin theta is equal to BN upon AB. This BN upon this length AB is 2L. You can see here BN is equal to what? Bn is equal to 2L sin theta. So from this triangle you can see this Bn is equal to what? 2L sin theta. So if you are putting here, this is QE, in place of Bn you can write down 2L sin theta. So torque is equal to what? Magnitude of torque, you can see here, torque is equal to QE 2L sin theta. Q into 2L I have taken together, E sin theta. This Q into 2L. So Q into 2L, that is dipole moment P. Magnitude of dipole moment P, E sin theta. So this will be the torque experienced by electric dipole when it is placed inside the uniform electric field. Torque is equal to PE sin theta. If you want to write in vector form, so torque is equal to P cross E. So this will be the vector form of this torque. Vector form I have represented here. So torque is equal to P cross E. So you can find the direction of torque by cross product method. If you are rotating a screw driver from where to where, dipole moment to direction electric field, to the nip of a screw, in which direction it advances, that will be the direction of torque. The vector form you can write a torque is equal to P cross E. Here P is electric dipole moment and E is uniform electric field, and tau is equal to magnitude of torque is equal to PE sin theta. Very simple. When torque, when electric dipole kept inside the uniform electric field, plus Q charge will experience force QE along the direction of electric field. Negative charge will experience also same magnitude force QE, but direction is opposite to electric field. So this is two equal and opposite force acting at action of line is different. That time they produce torque, yeah, moment of couple. So moment of couple or torque is equal to 1 of the force, magnitude of 1 of force, and perpendicular distance between the parallel forces. So this parallel force distance is Bn. So we have written the torque is equal to Q into Bn. Bn is equal to 2L sin theta, and we have put it, and we have find it the expression of torque. So here you can see sin theta maximum, the maximum torque maximum when theta is equal to sin theta maximum 1, so theta is equal to 90, so PE sin 90, so that is the maximum torque will be PE. This will when axis of dipole is perpendicular to field, like that. Suppose this is the field, then when perpendicular, at that time it experience maximum torque, and the maximum torque will be when theta is equal to 90 degree. When theta is equal to 90 degree, that time maximum torque, and that is P. And minimum torque will be when they are aligned, like that. That time what happen? When the line parallel to the dipole moment, direction of dipole moment is parallel to electric field. That time when theta is equal to 0 or 180, so that time torque is minimum, that is P is sin 0, that time 0. So you can see here, and the torque has always tendency, let this electric dipole parallel to electric field, that time torque becomes 0. That has always tendency to take the electric dipole parallel to electric field. The problem based upon electric dipole. An electric dipole is placed at an angle 60 degree with an electric field. See, any electric field is there, and dipole is forming. Suppose this is the dipole, and this forms angle 60 degree with electric field. Intensity 10 raised to 5 Newton per Coulomb. It experience torque 8 root 3 Newton meter. Find the charge on dipole. If dipole length is given 2 centimeter. So see here, this is the electric field, and this is the dipole. It makes at an angle 60 degree. So note down all the things. Theta they have given 60 degree. Electric field intensity E they have given 10 raised to 5 Newton per Coulomb. It experience torque. Torque they have given 8 root 3 Newton meter. And the dipole length we are assuming 2a. So see, 2L or 2a they have given 2 centimeter. If you are converting in meter, to 2 into 10 raised to minus 2 meter. So they want charge. So what will be charge there? See, when a dipole kept inside the electric field, angle made by dipole moment and electric field theta, so what will be the torque? The value of torque is equal to क्या होता है? Magnitude of torque P E sin theta. So from here P is equal to what? You can see P is equal to dipole moment. P is equal to Q, one of the charge, and distance between the two charges, equal and opposite charge, that is 2L. In place of P, if we write Q into 2L E sin theta. We want to find Q. What is Q? So Q is equal to torque upon 2L E sin theta. Torque they have given 8 root 3 remember always kept MKS system or CJ system. So we have kept MKS, meter kilogram second. Standard unit we have taken 8 root 3 2L. This is 2 into 10 raised to minus 2 E 10 raised to 5 and sine theta. Theta they have given 60 degree. Solve it. 8 root 3 2 10 raised to 5 10 raised to minus 2. This will 10 raised to 3 sine theta root 3 by 2. So 2 we cancel out, root 3 also cancel out. So this is 8 into 10 raised to minus 3 and unit will be coulomb. So what will be the charge? So charge will be 8 into 10 raised to minus 3 coulomb. So see, very simple problem is there. Firstly, note down all the things and what torque they have given. A dipole kept inside the electric field, it experiences torque, and that torque is equal to formula is PE sine theta. See one more problem based upon electric dipole. There are three charges plus Q and minus 2Q are placed at the vertices of an equilateral triangle. One equilateral triangle, side is A and three charges plus Q. So suppose one charge plus Q here I have taken, here another charge plus Q I have taken, and here minus 2Q charge. What is the dipole moment of the system? All sides are A. This is also A. What is the dipole moment of this system? Very interesting problems there. Three charges plus Q and minus 2Q is kept at corner of a equilateral triangle. Side is A. What will be the dipole moment of this system? See here what we know. If two equal and opposite charge minus Q and plus Q kept at distance 2L, what we know, the dipole moment P is equal to one of the charge and distance between the charge and directed from negative to positive. यानी डायरेक्शन इसका कहाँ से कहाँ होता है बच्चों? डायरेक्टेड फ्रॉम नेगेटिव टू पॉजिटिव. इट इज वेक्टर क्वांटिटी. डायरेक्टेड नेगेटिव charge negative to positive charge. And this will be the direction of dipole moment. Q into 2L. So see, here two equal and opposite charge if you want to convert. So this minus 2Q I can write as minus Q and minus Q, two charge. If I have considered. So minus Q, they will become minus 2Q. So what happen? Minus Q and plus Q. One dipole is here, minus Q and plus Q. Another dipole is here and distance between the dipole is A. Here also distance is A. What will be the dipole moment of system? This minus Q and plus Q. Another dipole moment, and both are vector quantities, we can find the resultant. So same thing we will apply here. We will take two dipole and their resultant. So see, first dipole. If I have taken here first dipole, what happened? First dipole minus Q and plus Q. So dipole moment due to charge plus Q at A and minus Q at C. ठीक है, suppose this I have given P1. So P1 is equal to what? Q into distance between them. So this is QA and direction is okay, directed along CA. This will be the direction. Same way, dipole moment due to charge plus Q at B and minus Q at C. This minus 2Q charge I have taken break into two parts, minus Q and minus Q. So this will be P2 if I have taken. So Q into A. So this is also magnitude is QA and directed क्या हो गया बच्चों? Directed along CV. You can see it. Two vectors P1 and P2. Angle between them is 60. The magnitude of P1 and P2. This is QA. So what will be the resultant? The resultant of two vectors. Both have same magnitude QA and angle between them is 60. If you are breaking it in form of components, so P1 has two components. One is what? This is P1 cos, this angle becomes 30. So P1 cos 30 and here P1 sin 30. Same way this P2 has two components, P2 cos 30 and P2 sin 30. You can see here P1 and P2 have same magnitude. So P1 sin 30, P2 sin 30 will cancel each other. P1 sin 30 and P2 sin 30 will cancel each other. So what will be the resultant? So you can see here, this will be the direction of resultant. Total 60, so this is 30. So what happened? The resultant dipole moment is equal to P1 cos 30 plus P2 cos 30. This is QA cos 30 root 3 by 2 QA root 3 by 2. This is root 3 QA. What will be the resultant dipole moment? Magnitude of resultant dipole moment P is equal to root 3 QA and direction is bisector of angle where minus 2 and directed along bisector of angle where minus 2Q charge is placed. यहाँ पर minus 2Q charge रखा हुआ उसका angle bisector, that will be the direction of this resultant P. You can see here what we have seen, the dipole moment of this system is root 3 QA and direction is the along line which is bisector of angle ACB, or you can say the bisector of that angle where minus 2Q charge has placed. So here we have taken the system by separating two individual charge system plus Q minus Q plus Q minus Q, and we have found the net dipole moment.